Hello students, in this short video I will tell you about the nth term test for infinite series. And this is sometimes called the divergence test or the test for divergence because it can only be used to tell if a series diverges. It cannot be used to tell if a series converges. So here's what the test says. It says if I have an infinite series, n equals 0 to infinity of an, and it does converge, then the limit of the individual terms in the series as n approaches infinity must be 0. Now, a logically equivalent statement is to say that if the limit as n approaches infinity of the individual terms in the series is not 0, then the series diverges. And so this is why it's called a test for divergence. Now, what you can use this test for is to prove a series diverges. Because if you take the limit and it's not 0, then you can conclude that the series diverges. Now, if you take the limit and it is 0, you cannot conclude that the series converges. Because, see, the logical implication goes the other way. It says if it converges, then the limit's 0. It does not say if the limit's 0, then the series converges. So you cannot use this test to tell if a series converges. Now, the advantage of this test, and the reason we use it sometimes, is because it's very easy to apply. Even though it can only tell you one thing, it can't tell you another thing. So let's look at a few examples, the ones I have written there. So this first one, we have n equals 0 to infinity. You notice sometimes I have the index starting at 0 and sometimes I have it starting at 1, and that won't make any difference. It will only depend on what eventually happens in the series. So n equals 0 to infinity of just 1. Now in this case, this means that an equals 1 for all n. And so the limit as n approaches infinity of an is just the limit as n approaches infinity of 1, and that's just 1, and in particular it's not equal to 0. So we can conclude that the series diverges. Now you knew this anyway, because the sum from n equals 0 to infinity of 1 is just 1 plus 1 plus 1 plus 1 plus, and then this goes on forever. It obviously will not approach a limit. The sequence of partial sums, that is, will not approach a limit, so the series diverges. But this is an example of the type of series that you could use the divergence test for. And then the second example on there is even worse in terms of how it diverges. So this is n equals 0 to infinity of just n. And here we have the nth term an equals n. And so the limit as n goes to infinity of the nth term an is just equal to the limit as n approaches infinity of n, and that's infinity. That's what it says. N is going to infinity. So we can conclude that this diverges same way. Now let's look at the third example, and this is where it gets a little bit subtle. This, you recognize this series. Now I have an n equals 1 to infinity of 1 over n. And the reason I put 1 here is just so I won't have division by 0 in the first term. Now here, the terms are 1 over n. And so the limit as n approaches infinity of an is the limit as n approaches infinity of 1 over n, and that's 0. But the series diverges. So this example is important to remember. You cannot show that a series converges. And this is what I said about the logical implication. The statement that the limit is 0 does not tell you that the series converges. It goes the other way around. If the series converges, then the limit will be 0. So if you apply this test and you get a limit of 0, it doesn't tell you anything. It just, so here the test didn't tell me anything. It didn't let me conclude whether it converges or not. Based on this test, it might converge because the limit is 0. See, this test doesn't rule out the possibility that it converges. We know on other grounds that it does not converge, it diverges. But this particular test won't tell you that. So then let's look at the fourth example. And this one, n equals 1 to infinity, 1 over n squared. Here, the nth term, an, is 1 over n squared. And so the limit, as n approaches infinity of an, is the limit as n approaches infinity of 1 over n squared. And this is 0. Same limit as it was with 1 over n. So in this case, we know that the series converges. And we know what it converges to. I told you this. Or if I didn't, then I'm telling you now. So the series converges to pi squared over 6. So once again, this particular test tells you nothing. Because we saw a case where the limit was 0 and the series diverged, and now we're seeing a case where the limit is 0 and the series converges. So the only way this test will tell you anything is if the limit's non-zero, or if the limit doesn't exist, and then you can conclude that it diverges. So hopefully this clears up what you can use the nth term test for.